So today we'll go over the warm-up, which is just reminding ourselves of what the subsets are and which numbers belong to which. The agenda for the day, we'll just finish up that rational and irrational. We're only gonna take like 5 minutes. The back was like super quick, so I'll just give you the main idea. We might not do every problem on it. Today, you guys have seen solving equations before. We'll kind of start basic and work our way up, just to retrain our brains here. We'll do some examples in practice, and that will be that. So that's the idea. If you see something you're not understanding, please ask, and we'll go from there. So name all of the subsets to which each belongs. So every number is always going to start with either rational or irrational. This one is rational, right? We get rid of the fraction. So under rational, there were 3 more groups. Is this natural?
No.
No. Is it whole?
No.
Is it an integer?
Yes.
Yes. So this one would be a rational and it is an integer. So that's that. Number 2, we always start with, is it rational or irrational? If it's a square root of a non-perfect square, it is automatically irrational. So we always know that pi is irrational, but also if you have square roots of non-perfect squares. Number 3, in that case, you look, you would have to kind of do a little simplifying. Like, we don't know the square root of 26. We actually do know the square root of 1 over 144, because since those are both perfect squares, that actually ends up just being 112. So that is a rational number. We can write it as a fraction, but then it does not fall into any of the other categories. So does anyone have a question on those? Why we put something into a certain subset? That's basically, like, you're gonna hear me throughout the year be like, oh, your answer's gonna be an integer. So I don't want you to sit there and be like, I don't remember what an integer is. So that's why it's good to go over that stuff. Just a little vocab reminder. When we eventually take an assessment, who knows when that'll be? I'll let you know when it's coming. But I will ask you some stuff about those subsets, so just as a heads up. Are there any questions on the warm-up? Fabulous. Can you find your worksheet from yesterday? Behind mine. I'll probably go toward the camera. There we go. I found mine. We had done the front. The back, I'm just going to go through quick. We're not going to do every problem. It's just the idea. Sometimes this stuff randomly pops up on like assessments, like MCAS and stuff. But we're just gonna hope we don't have to take the MCAS. On the back, it just asks about combining rational numbers with irrational numbers. That's the main idea of the math. So we're not gonna do all of these, and that's okay. So it says for a sum or product, sum means we're adding 2 things, product means we're multiplying 2 things. Determine whether the result is rational or irrational. Write R or I. So what do we think? For 27, I'm just adding 2 fractions together. I don't actually have to add them. I don't care. If you care what 5/8 plus 3/5 is, go for it. I don't really care. All I'm asking is, will the answer be rational or irrational? Which would it be? Deep breath. Anyone, just yell. You have 50% shot. You're going to be rational. Rational. Good. Yeah. If you add 2 fractions, you get a fraction. That'll be rational. So number 27 will be rational. I'm just going to write R. 28. Once again, if we add 2 fractions, it's rational. 29 is where it looks a little different. You have a fraction, which is grade -1/2, but you're trying to add the square root of 2. We know the square root of 2 is irrational because it's the square root of an imperfect square. Basically, anytime you see that irrational part, it's going to make your answer irrational. That's the main thing to look out for. So 30, since you have that square root of 5, it's irrational. 31, 2 regular fractions, you'll get a regular fraction. 32, when you see that square root of 2, that's irrational. 33, don't get tricked, square root of 36 is 6. We can multiply by that by a fraction, that would still be rational. And 34, when that square root of 11 would make it irrational. So they're quick, it's just combining. We're not gonna do all those ones at the bottom, they're just like quick little things. They basically ask the same questions, just without numbers. The ones I wanna look at are 39 and 40. 39 says, can the sum of two irrational numbers be rational? So can I add two irrational numbers and get a rational answer? The answer is no. So 39 is no. We'll do this later in the year, but if I do something like the square root of 2 plus the square root of 2, that doesn't magically make it rational. You just get 2 square roots of 2. So we can notice, so these are irrational. You get an irrational number. I wanted to point out 440 to you. Can the product of two irrational numbers be rational? This one's a little tricky because the answer is yes. So if I did something like the square root of 2 times the square root of 2, we can probably guess when you multiply square roots, you just multiply the numbers underneath. That would give me the square root of 4, and we know that that's just 2. So you just have to be careful. Once again, this is just, we're not like getting super detailed. We do a whole chapter on radicals with those square roots. But those were 2 that just randomly pop up, and those type of questions have been on MCAS before. So I like to really show it to you. Who knows what MCAS is going to look like in the future? We'll just, hopefully they'll need to take it. So the rest of the worksheet, if you want to look through it, you can. It's really just like the same stuff from the top. So we were just finishing it up. So you can put that somewhere. Frame it if you want. So what I need you to do is once that's away, can you please take out just a piece of paper to write on? So just regular notes, whether it's a notebook, piece of paper, whatever. So I'll give you a second to get settled. All right, this is Algebra Accelerated. You guys, good. So I'm going to throw up a few equations. These are like basic equations. So just 1 or 2 steps. I'm going to give you a few minutes. I'm going to ask you, to the best of your ability, can you try to solve these equations? We'll see how we're feeling, if there's any steps that's giving us issues, and then we're going to add on to this. But like, look, this is our first equation. So I'm going to say solve. I'm going to do that. All right, so I'm going to give you a few more super basic ones. Just warming our brains up here. Change this last one, make it a fun one. So I'm just gonna take attendance while you guys are doing that, so give me a minute, so input everything. So nothing too crazy, maybe one, I think there's a few 2-step. So if I asked you to solve for the unknown, I've made up all X's, you can make them whatever you please. Can you do that as kind of just a warm up and an intro to what we're gonna do with some solving equation stuff today? No, that's happening. It's just confusing.
How are you here, folks? Let's take a look. What is the place to meet the girls and identify those procedures kind of over the line
If you can't do something, that's fine, just write it down, nothing else. If you forget, or if you're just, your brain's not working at full capacity yet.
So yeah, what is a variable that Jack is trying to find out about?
That's your feeling.
What is one variable here?
There we go. One,
Favorite character, Gold Star. Yeah.
really, it's getting into it over there. We'll go over these bad boys. Alright, so oh yes,
How are about them?
yeah, just right past them. So I apologize in advance. Usually on a day like this, we'd be working together, you'd be chatting, we'd have people come up to the board. You know, that's kind of out the window. So I'm sorry if it's semi-ish. But we'll just kind of do our best to get through. Our main goal is, okay, we're gonna be, our first chapter is solving equations. You should have at least be semi-familiar with it. So this is kind of just a check-in to see that you're on the right track with the basics. So as we add on, you're okay. So if you see something you're not getting or your answer doesn't match, please ask. So number one, when we solve an equation, we find the variable. Our main goal is to isolate it. We're gonna do that using the opposite sign of whatever is attached to it. So since it's plus 2, we'll subtract 2. And your first answer is x equals 5. Any problems? That's too crazy. Number 2, these are connected with multiplication. We are going to divide. X equals 8. This is connected with addition. We really look at the sign of this that we want to cancel. It's positive, so we are going to subtract it. We'll get x equals 2. There we go. And last but not least, well, not last but not least, but these are our one-step problems. That's connected with division. The opposite of division is multiplication. And that would give me 16. Any problems with one-step equation? So I'm not going to teach those to you. You guys kind of know the idea. But I like to not kill you to start with. Then we go to two-step equations. So in this case, if we have multiplication and we have addition, we're always going to get rid of the constant first. So we're going to subtract. That gives me that. And then I will divide after that. X equals 4. And then last but not least, for this one, you can do two things. If you have a fraction in front, you can multiply by the reciprocal, because with the reciprocals, we'll cancel just to be 1. Or I'll show you another step in a second. What would that give me? 9?
Yep.
So, take a second. Who right now is saying, this is really easy? Yeah, pretty much everyone, right? Like, they're pretty basic. I know you guys do equations in previous years. Even with last year being a semi-disaster, you probably got to them at some point. So once again, we'll just kind of warm up our brains with the basics, and then we'll get into more complicated. So a few things we're gonna do, we're gonna kind of add on to this as we go, adding steps. I'm sorry to tell you, I'm a big fraction fan, so we'll do a lot of fraction stuff. We'll have a lot of answers that are fractions, all of that is okay. I do not accept decimal answers, so I'm just gonna throw it out there. If there's a fraction, I expect your answer to be a fraction. So just as a heads up, I like exact answers, not approximate. So that's something to maybe get used to.
What about improper fractions?
I'm gonna be honest, I like improper. I hate mixed numbers. Or if you gave me a mixed number, I'd probably be fine with it, but
Okay.
get used to impropers, they're way cooler.
Okay.
Okay, so let's look at some things, ooh, I feel like, that maybe it's either been a while or you've never seen. Now, reminder, we're not gonna use calculators in class. Obviously, if you're out of class, you can kind of use one, because I'm not with you. But in class, we're gonna try to do the no calculator route, build those brains up. So we're gonna solve. Let's start. 2/3 x plus 1/6. I won't make it too mean. I was gonna put like a lot more things. I'll do that in a minute. Equals 5/9. So we see an equation with all fractions, which if you have your fraction phobia, you might be having a little heart attack, but that's okay. What I don't do, especially without calculators, I don't just start to solve this like normal, because it's gonna be annoying, right? If I subtract 1/6, then I'm gonna have to find a common denominator, combine them, then I have this, and I have to deal with that. So what I'm going to do when I have a fraction equation, I'm going to, first step is cancel all of the fractions. And I'm going to do this by multiplying everything by the common denominator. You're gonna see 1 second, that's gonna make your life way easier. So when we look at our denominators, 3, 6, 9, what's the common denominator? 18, right? So I'm gonna multiply everything by 18. Now here's how I do it, because I'm not using a calculator. So I'm doing this in my head, but I'm gonna show you my steps off to the side. In my head, I'm saying 18 times 2/3. What I do is I reduce this fraction. 18 over 3 is just 6. 6 times 2 is 12. So I do that every time. This is how I've done it and how I still do it. So I kind of just do, okay, what's 18? I put it over that, whatever's in the denominator of that fraction, and reduce it, and then I multiply it by the top. So if I have 18 times 1/6, I say, oh, 18 over 6 is just 3. 3 times 1 is 3. And then last, I have 18 times 5/9. 18 over 9 is just 2 times 5 is 10. What I don't like to do is I don't want to do 18 times 5. I don't know what 18 times 5 is on the top of my head. Who just knows that? And then divide, that's a pain. So I do the reducing first, and then I multiply because the numbers are way easier. We're left with this, which is nice, because that looks better. So I'm just gonna do a quick subtraction and division. My answer is a fraction, that is okay. I'm going to leave it as a fraction. Please do not give me decimal answers. So, equations with fractions is something we do randomly run into kind of a lot. I don't know why it just happens all the time, because it's super cool. So we just want to make sure when we get to an example like that or a problem like that, you don't freak out because you see fractions. You have an idea of what the process is that you're going to go through. So you're going to say, well, I really don't want to deal with the fractions. So you can do that common denominator step. And then from there, it just makes your equation way easier to actually solve. That's something I like to show you. So before we do the next thing, I'm gonna have you try one. So an equation with all fractions, no calculators, can you solve this? Oh, I won't give you two crazy numbers, I'll be semi-nice to you today. Let's go with 3/4 minus 5/12 x. Sorry, I'm just trying to think of nice numbers that aren't gonna kill you. 6, 7, 8, we'll do equals 1/6. Just trying not to kill you with the numbers. So if I said, hey, you have an assessment today, and you would say, woo. And I'd say, okay, but you're not using a calculator. I just want you to get to that problem and not have a heart attack. So try to go through the steps that we just went through and see if you could follow them. I'm gonna take a sip of water, I'm gonna turn around. If you need help, just raise your hand. I can attempt to help you from 6 feet distance. I'll give you another minute or two. I know sometimes it just takes a second to digest those. Maybe one more minute. Try to have an answer. If it's a fraction, that's okay. I just randomly made those numbers up. It probably is a fraction. All right, let's see how you did. Just kind of a self-assessment, see if you followed on. If you didn't, that's okay. This is like the third problem of the day, and we really just started. So just fix what you got. If you have questions, let me know. So when I get to a problem like this, I automatically say, I just don't want to deal with it. It's annoying. So I'm going to do that process where I'm going to multiply everything by the common denominator. In this case, it's just 12. Remember, technically that's 12 over 1. I'm just writing it as 12. I don't need to write it as a fraction. So I kind of do that cross simplifying first, and then I multiply just to make my life easier. So in my head, this is what I do. 12 divided by 4, 12 over 4 is 3, times 3 is 9. So that's just a step to get used to if that's how you haven't been doing it that way. So 12 over 12 is 1, times 5 is 5. That has an x with it. 12 over 6 is 2, times 1 is 2. So without too much work, once you kind of get used to that simplifying step, our equation looks way nicer. And now we can solve it. Remember, we're trying to isolate x, so we're going to get rid of the constant first, the number that's by itself. It's a positive 9, so I'm going to subtract it. we got -5x equals -7. And then we are going to divide. Our final answer, we notice we have two negatives, which is going to make a positive, and we would say our answer is 7/5. Once again, leave it improper. Don't do an extra step and say 1 or 2/5. It's a step that's not necessary, excuse me. It's actually easier to leave it improper as we do stuff in the future. So right now, does anyone have a question with that problem? Okay. So if you have a question, just ask. Sorry, I forgot what time this class is. What's this about 4:01? Okay, so we have both. Just a few things, because I'm just randomly thinking about them. So I decided for after-school help, I wanted to try to kind of be semi-fair to both cohorts. So I will be after school on Tuesdays and Thursdays. I'll be here just till 2:30. So you are more than welcome on a Tuesday to come by. I know some of you take the bus, which is, I'm like, well, you can't really do much. So the other day, the Thursday, I'm also, for both days, I'll be on virtually as well. So you're just going to, if you had a question for me, or if you want, I don't know, me to explain something to you a little bit better, feel free to drop by on Tuesday or on Thursday. You can log into your Google Meet just using Sherman Remote. That's how you always sign in. And I will be here. You can ask me questions. You can clear up anything that you need. I can give you some extra practice. But that's kind of how extra help will work. So I just wanted to explain that. Because today's Tuesday, so I will be here if you need anything after school. Just till 2:30, but try to split it up between the days to make it even. Yep.
After the bathroom.
Absolutely. Just grab a pass and hand on that. Okay. Any problems, issues? We'll do one more type of problem, try one or two, and then we'll be it. Okay. So we dealt with fractions. Those were a blast and a half. Would you rather, okay, I'm gonna give you a choice, because I don't know if you would do. Would we rather do equations that have decimals? So you have to give your answer as a fraction, so you have to do that. Or would you rather do equations where you have to combine like terms? With just integers?
Like terms.
Like terms? I wasn't really feeling the decimal either, so I was just throwing it out there. Like, I don't think my brain is like, then you have to convert them, then there's all big numbers. I just couldn't do it, but I was just asking. I was just trying to be nice. Yeah, I'm gonna go like terms. We'll do the decimals. We'll do the decimals later. They're a big pain in the butt when you can't even calculate it. Okay, so like terms, probably looks semi-familiar to you because you guys have seen equations before. Let's start with the basic one, then we'll work our way up and do a few that are a little bit more complicated. And we'll see some distributing too. We'll kind of do those two steps together. So let's say, so we're gonna see two basics and then we're gonna make a complicated one. So just the idea, once again, you may have seen this before, I'd rather always kind of just go over it than just assume that you know it. So to combine like terms, obviously there's a lot going on in this equation. Our main goal is to kind of make it, combine things together to make it a little bit easier to solve. So when we say like terms, things that are alike, that makes sense. Just make sure you know where your equal sign is. I'm a big sometimes there's a lot going on. I just need to organize my brain. So sometimes where I see the equal, I just kind of just draw that line. Just so I notice that on the left, I'm focusing on combining stuff. I'm also an underliner. So I find anything that has an X, and I'm going to combine those. Just pay attention to whatever sign is in front to use to combine them. So if I had 2x plus 3x, that's 5x. And I'm going to add 7x to get 12x. So it's just adding. You've done that before. It's just more staying organized than anything else. I do notice that we have two numbers. We call those constants. So you'll hear me say that word a lot. So constant is just a regular number in an equation. So I'm going to combine my constants. I have a 5 and an 11. That's going to give me 16. Our main goal is always to get down to a two-step equation because we know how to solve those. We are going to move our constant first. I'll subtract 16. I get 12x equals -3. Please pay attention to signs. Those are important. And I'm going to divide by 12. Please, if you give me a fraction answer, which is a fraction, that's fine. You can reduce it, do so. So my final answer would be -1. So just the idea of combining like terms gets us down to a two-step equation, and then you can solve it. Any questions on that one?
No.
Right, we're just going to do one more together, and then you're going to try one, and then that'll be it. So the other thing we'll talk about is distributing. Once again, you've done it before, but let's look at an example. Let's just do, I can't really make these too crazy here. We get to the fun ones, we'll do those next week. So you distribute when you see a set of parentheses. So once again, I'm kind of a visual person, so I would just draw that line. When I see that parentheses, I'm going to take what's on the outside and distribute it in. So everything on the inside gets multiplied by 3. So if I were doing that distributing step, I would get 6x. Once again, don't lose signs. That will give me -21. The main goal of these steps, whether it's combining like terms or distributing, is to get to a two-step equation, which we can now solve. We'll move our constant first. And then we will divide. You're saying that doesn't divide evenly, so that's your answer. If you can't simplify it anymore, perfectly fine way to write an answer. You do not need to give it to me as a mixed number. Does anyone have a question with combining like terms or distributing? Did you guys do that last year?
Yeah.
Okay, so like I hate just like assuming you did it because people are coming from different schools, different teachers, quarantine. But I like to like reintroduce. All right. So since you're such pros, this is going to be your wrap up. All right, you ready? So, let's see, we got plus 2x minus 1 equals, this is probably going to be a real nasty answer because I just made those numbers up, equals 3, my favorite number. Okay, so you're going to try that. I'll give you a few minutes. I'm not going to rush you. So we see a lot going on. We see a lot of distributing. You can see those clearly from where the parentheses are. And you see that there's a lot of stuff going on, so we're going to have to combine. So can you stay organized enough to try that problem? If you need help, let me know. Again, I'm not gonna come too close to you, but God bless you, but we can, still communicate. Give you another minute or two. Do you want to keep people still working? Take your time. Another 1 minute. All right, let's see how far we got. Let's see if we got the answer. I have no clue what the answer is, so we'll go with it. So this is like 80% of math is just staying organized. It's when you get all sorts of crazy that things go awry. So I'm gonna try to stay as organized as possible. I'm gonna go through and distribute first. So that 2 extra stays. I'm gonna distribute in here. That should give me plus 3x minus 3, because 3 times -1 gives me -3. And that 6x just kind of chilling. Be careful. This is the biggest mistake I see. You're not distributing 6x. In this set of parentheses, you're just distributing this negative sign. Think about it as just being a -1. We don't write 1 below, we just assume it's there. So if I just distribute that minus or that negative, that should give me -x, and 2 negatives should give me +2. So just make sure you're on the right track there. Then I have a 5x. Then I have an 11. Then I distribute in, and I get plus 2x minus 2, and that's going to equal 3. Okay. So now I'm going to go through, I'm going to kind of do it as I'm going. I'll combine all the x's. So 2x plus 3x is 5x. Plus 6x is 11x. Minus x is 10x. Plus 5x is 15x. Plus 2x is 17x. Did other people get that?
Yeah.
Okay, that makes me feel better. Sometimes P.S. If you see me do something wrong, please tell me. I do it all the time because my brain gets kind of fried doing math all day, but feel free to shout out if you see me do something wrong. Let's do our constants. -3 plus 2 is -1. Plus 11 is 10. Minus 2 is 8. Did you look at that?
Yep.
Okay, feeling better about myself. There we go. So it's just awkwardly spaced right now because we're putting it around. I'm going to subtract my constant. 17x is going to equal -5. I got my final answer was -5/17.
Yep.
Ooh, what if you got that? If you didn't get it, it's fine. Let's be honest. This is our first real day of notes. So if you didn't get it, just try to go back and kind of backtrack and see what went wrong so you don't make the same mistake in the future. So that's the main idea.